Hi everyone, this is Julia. I'm Rivers class of 2015, and today I'll be explaining thermochemistry. So I've adapted the slide that I'm going to show after this one from a website called www.chem.tamu.edu. So if you're interested in reading more about this or seeing the original version, that's where you should definitely go. So thermochemistry was one of my favorite topics in Biochem 2 and in AP Chem, and I especially like the heating curve, so that's what I'll be explaining today. So I've drawn a typical heating curve. The only difference is I've shaded in the areas underneath to make it a little clearer which sections I'm speaking about. But this is a heating curve of water. So we have the 0 degrees, we have 0 degrees and we have 100 degrees. So obviously we have 0 degrees here and 100 degrees up here. So the first stage that we talk about is the solid state. So that's this whole area right here, this whole group. And in this dark navy stage, this is when everything is frozen, it's all ice, and it's less than 0 degrees Celsius. The next phase, which is when it switches from solid to liquid, is I think what confuses most people, myself included. And this is where individual particles they're all staying around 0 degrees on a whole, but individual particles are shifting from being a solid to a liquid, so they're all transitioning. So that's the main difference there. So that's why this changes color a little bit in this section here. Our next section is when the whole thing is a liquid. So there's no change of state in this section here, but the temperature is rising. So in this section that I've circled, it goes from 0 degrees all the way up to 100 degrees. So this middle state here is where it takes a long time because the whole thing has to change temperature in such a great difference of temperature, and water takes a very long time to change temperature. But nothing is changing from a liquid, it stays a liquid. And even at this very top point right here, every single molecule is a liquid molecule. So then we get to the next phase, which is liquid and gas. And in this next stage, everything stays at about 100 degrees Celsius, but some molecules are transitioning to a gas phase and some are staying in the liquid state. So this is another one, just like this, the solid and liquid are very similar, the solid to the liquid and the liquid to the gas. And then this last state is when it's all a gas, and this is similar to this liquid state, and it's similar to the solid state in that everything is the same transition state, and it's just increasing temperature. So then there are a few other important terms that are good to know. So some more obvious ones first. When the temperature is going down, in this point right here, when it's going from a liquid to a solid, it's freezing, and when it's going from a solid to a liquid, it's melting. The ones up here, though, are a little less explanatory. So when it's going from a liquid to a gas, it's vaporization, but when it's changing from a gas to a liquid, it's condensation. And then there are two latent heats that you need to know for calculations. I don't have the numbers, but I definitely know the terms. And the term for the one right here is the latent heat of fusion, so when you're doing calculations, you'll need that. And it'll just depend on how much of the water, in this case, how much of the material you have, in order to calculate how much heat is needed. And then up here, the one is the latent heat of vaporization. So those are the two calculation conversion factors that you'll need to know in order to do all of your thermochem calculations. And I hope that was helpful.